Hi everyone, welcome you all to the Brilliant Group of Institution. Here we are going to discuss the most important NCERT question from the chapter Amines, the organic chapter Amines for your term 2 examination. Alright, so we can enter into the next one. Give one chemical test to distinguish between the following pair of compounds. Very important question. Dear student, mainly in this chapter we are dealing with what are the distinction tests. One is called Hinsberg test. Hinsberg test. You know, Hinsberg test is the reaction with the benzene sulfonyl chloride. It is a test mostly we are using to distinguish between primary, secondary, tertiary amines. Second one is called carbylamine test. You know, carbylamine test is also known as isocyanide test. Carbylamine test is also known as isocyanide test. Dear all of you, carbylamine test is given by only primary aliphatic and aromatic. Primary aliphatic and primary aromatic amines only will give carbylamine, or the foul smell isocyanide formation. Yeah. So carbylamine test is only given by primary aliphatic or primary aromatic amine. And the third one is called nitrous acid test. Nitrous acid. Just to be discussed now before one of the question. Nitrous acid means HNO2. What is this test, dear student? Aliphatic amines, especially primary aliphatic amines, when it is treated with the HNO2, we said you will get a unstable compound, right? Unstable compound. Immediately it will react with the water and it will give you alcohol. When a primary aliphatic amine treated with the nitrous acid, it will give you a unstable diazonium salt. It is immediately react with the water and giving you alcohol with the evolution of nitrogen gas. We discussed now one of the previous question with HCl. Whereas, what about aromatic amine? If you are using a aromatic amine, dear student, aromatic amine, when you treat it with the nitrous acid, it will give you a stable compound due to resonance. A stable compound immediately we cannot dissolve in water, so it won't give alcohol immediately with the evolution of nitrogen. So this is the most common distinction test we are using in this chapter. Let's go for the question. How you can distinguish between methylamine and dimethylamine? Dear student, what is the compound methylamine? Methylamine is CH3NH2 and dimethylamine is CH3CH3. Dimethyl group on a amine. This is dimethylamine. You can see that it's a primary amine, primary aliphatic amine. It's a secondary aliphatic amine. How we can distinguish between a primary and secondary amine? We can use Hinsberg test. Hinsberg test, what we can discuss later, and carbylamine test also. So what is carbylamine test? You know, carbylamine test is only given by primary aliphatic, primary aromatic amine. One is secondary, right? So we can say it can give carbylamine test, it won't. Okay, so carbylamine test can be used, or a Hinsberg test. Question number 2, secondary and tertiary amine. How we can distinguish between secondary and tertiary amine? We can use Hinsberg test, right? Secondary and tertiary amine we can distinguish by Hinsberg test. Aniline and benzyl chloride. What is aniline? You know, benzene with NH2 is called aniline. And benzyl amine means, you know, benzene with the CH2 is called benzyl, with the NH2 is called benzylamine. How we can distinguish between aniline and benzylamine? Dear all, aniline is a aromatic primary amine. NH2 group is there and nitrogen connected to the aromatic ring. So this is a primary aromatic compound. What about here? It's a primary aliphatic because nitrogen is not directly connected to benzene ring, directly connected to one alkyl group. It's a primary aliphatic one. So which test can be used? We cannot use carbylamine test because carbylamine test is given by both primary aliphatic and primary aromatic, right? So which one is possible? Dear student, we can use nitrous acid test. Here we can follow nitrous acid. Nitrous acid test. Why? It's a primary aromatic amine. when reacted with the nitrous acid. Means aniline, when it is reacted with the nitrous acid, the compound is unstable. But this is an aliphatic one. When it is react with the nitrous acid, it will give you a unstable compound. When it is react with the water, it will give you alcohol with the evolution of nitrogen. So aniline and benzylamine can be distinguished by nitrous acid test. What about aniline and N-methyl aniline? You know, aniline means benzene with NH2. N-methyl aniline. What is N-methyl aniline? On the aniline, it's connected to a methyl group, N-methyl aniline. You know, dear student, this is a primary aromatic amine. Correct or not? I mean, NH2 group is there and nitrogen directly on benzene, primary aromatic. What about this? This is a secondary amine and it is aromatic because NH group is there, therefore secondary. Nitrogen directly connected to benzene ring, therefore secondary aromatic amine. Can you please tell me, dear student, how you can distinguish between a primary aromatic and secondary aromatic amine? Can we use carbylamine test? Yes, because carbylamine test is given by only primary aliphatic and primary aromatic. So he can give carbylamine test, he can't. Okay, very carefully study. We can discuss detail about what is carbylamine test and Hinsberg test. This is just to identify which all compounds can give or not. What is a test really with a chemical equation? We can study in the upcoming question. Reasoning question, dear student. Account for the following. pKb of aniline is more than that of methylamine. Dear student, generally basicity, how much the compound is basic, you can explain in different way. Either by using Kb value or by using pKb value. Dear all of you, if the Kb value greater increases for a system, we can say the basicity of the base is greater. Okay, so Kb value, if it is greater for a base, its basicity very greater. Then what about pKb? Dear student, pKb value increases, just opposite, basicity decreases. Very careful about these 2 points. So Kb value increases, basicity increases. pKb value increases, basicity decreases. We can go for the question. Your system is aniline and methylamine. What is aniline? Benzene with NH2. You know, the nitrogen contained lone pair. Methylamine is CH3 NH2. CH3 NH2. Okay. We studied that why aromatic amines are very less basic. Dear student, aromatic amine in the sense the amine nitrogen is directly connected to benzene ring. You know, benzene ring is highly conjugated. This lone pair on nitrogen is shifted like this and it will undergo resonance. So generally aromatic amines can undergo resonance. You know how to draw the resonance structure of the compound. We will get these two double bond, nothing happen. Here it become a double bond, NH2, right? And this bond shifted here. So it will get the electron with a negative charge, here positive charge, etc. Okay. The main thing, dear all of you, you know why amines are basic? Amines are basic because the amines, the nitrogen contain a lone pair. If it donating the lone pair, it is called Lewis base. A substance, if it donating a pair of electron, it's called Lewis base. So all amines are bases because they can donate lone pair. What is the problem with the aryl amine? Why aryl amines are very less basic? The lone pair on nitrogen is involved in resonance. So is it available for donation outside? No. So it is less basic. So we know aryl amines are less basic in nature. Less basic. Less basic means what, dear student? I told you Kb value greater, basicity greater. So less basic means Kb value lesser, pKb value greater. Yes or no? Then what about methylamine? Dear student, in methylamine the alkyl group is connected to nitrogen where resonance is not possible. So resonance is not possible, and one more reason, you know, alkyl groups are electron donating group. Electron donating group, if it is present, they will give more electrons towards nitrogen and nitrogen become richer in electron. They can donate electron fast. Generally, one more reason, let me tell you, Electron donating group, if it is there, they will increase the basic character. Electron withdrawing group, they will decrease the basic character. Another component. Okay, so generally alkyl amines, when you consider, they contain alkyl group. Alkyl groups are donating electrons towards the nitrogen, and the nitrogen become richer in electrons, so it can easily donate the lone pair. Clear all of you? Therefore, pKb value of aniline is more. pKb greater mean it is very less basic than methylamine. Hope you clear? Second question. Ethylamine. What is ethylamine? Just let me just write C2H5NH2. Correct? NH2. I am just writing this. NH2 is soluble in water, whereas aniline is not. Aniline. You know what aniline is? Benzene with NH2 again. It is not due to resonance. Okay. Dear all, here when you consider, this is ethylamine C2H5NH2 and this is aniline. It is more soluble in water. When we can say a compound is soluble in water, if the compound have an ability to make a hydrogen bond with the water, they are soluble in water. Let me take a water molecule. You know, water molecule is H2O, right? H2O is there. H2O. Here you can see that in our aniline, there is lot of hydrogen. See in a primary amine, hydrogens are there, nitrogen lone pair is there. Here oxygen is there, so hydrogen oxygen can make a hydrogen bonding, right? Hydrogen and oxygen can make a hydrogen bonding. So when you consider a general alkyl amine with the water, they have an ability to make which bonding? Intermolecular hydrogen bonding. If they make a bond, they can soluble in water. But what is the problem in aniline? So you may think even aniline also nitrogen contain 2 hydrogen, right? But the problem is this ring. There are 6 carbon contain a benzene ring. You know, the hydrocarbon parts are hydrophobic in nature. Hydrophobic in nature. Hydrophobic mean water hating part. So aniline, the aromatic compounds which contain hydrophobic part, if it is there, they can't soluble in water. Let me conclude. Why ethylamine is soluble in water? Because they have an ability to make intermolecular hydrogen bond with the water. Whereas aniline is not soluble because they contain a hydrophobic aromatic ring. Next question. Although amino group is ortho-para directing group. Dear student, amine groups are ortho-para directing group. Electrophilic substitution reaction, aniline on nitration gives a substantial amount of meta-nitroaniline. Yes, it's a very important question. You may studied the part called nitration, electrophilic substitution. You studied nitration, bromination of aniline. Let me discuss about nitration. Nitration means benzene with the NH2 is called aniline. Nitration, you know, concentrated. We are adding concentrated nitric acid and concentrated sulfuric acid. Okay, this is the nitrating mixture. What will happen? Dear all, in this one, NH2 group is a ortho-para directing group. Ortho-para directing group means it will invite the upcoming electrophile into the ortho and the para position. You know, this is ortho, this is para. This is nitrating mixture, so the upcoming electrophile is which one? NO2 group. So NO2 group can goes to ortho and para position. You may studied what is the product going to form here. You are actually getting this is aniline. Okay, aniline. You are getting nitro group para. Nitro group meta, nitro group ortho. You have studied the percentage of the compound also. This is around 51%. This is meta product is around 47%. It is around 2%. Aniline is amine is a ortho-para directing group. So actually it has to give ortho and para products only. But it's giving a substantial around 47% of meta product. What is the reason? Dear student, the main reason is, here your species is aniline. Let me take the aniline species once again, NH2. Right, nitrogen with a lone pair. Now you're treating aniline with a high acidic medium. You see concentrated nitric acid and concentrated sulfuric acid. It's a very high acidic medium. You know, acidic medium contain H plus ion. H plus ion. So what will happen? You know, amine are basic in nature and H plus is acidic in nature. By donating this lone pair, it will take the H plus ion and it will form the compound benzene. Here NH2 and this is H. So totally it becomes NH3. Nitrogen donated the lone pair, so therefore it will get a positive charge. So NH2 group converted to NH3 plus. Benzene with NH2 we will call it as aniline. Benzene with NH3 plus is called anilinium ion. Anilinium ion. Dear all, anilinium ion, we can directly say that it's a meta-directing group. Aniline is a ortho-para-directing group. So we are expecting only ortho and para product. But here why we are getting meta product? Because of the formation of anilinium ion. Anilinium ion, see the nitrogen contain a positive part. It acts as a minus I group. So it making a meta direction. It making a meta direction. It will invite the nitro group into meta position. So aniline, if it is there, it will give ortho para positions only or ortho para products only. But here aniline is basic in nature, little basic in nature, and it is reacting with a high acidic medium. When this aniline react with the acid, it forming very the compound meta, just like a meta directing group, anilinium ion. So therefore a sufficient amount of around 47% of meta product can be formed. So the reason is because of the formation of anilinium ion. Next one, aniline does not undergo Friedel-Crafts alkylation and acylation. What is the reason? You know, generally when aniline, again here aniline is an ortho-para directing group. You know, Friedel-Crafts alkylation mean addition of alkyl group, acylation mean addition of acyl group. Here, when you treated, you know, suppose it is Friedel-Crafts alkylation, if you want methyl group, you will take methyl chloride in presence of the catalyst anhydrous AlCl3, correct? Where CH3 plus is the electrophile, it will go to ortho and para position, correct? Why this reaction is not happening here? That is a question. Why the aniline not undergoing Friedel-Crafts alkylation and acylation? Dear all, carefully listen. Aniline is the one we have. This aniline, the nitrogen, I told you it having a lone pair. So nitrogen is little electron rich compound because an unreactive lone pair is there, right? It is treating, what is the catalyst using in this Friedel-Crafts reaction? Anhydrous AlCl3. Let me take AlCl3 here. You know, AlCl3. This is the catalyst we are using. Normally, catalyst won't react in a reaction. But here, aniline is a electron rich compound. AlCl3 is an electron deficient compound. Why it is electron deficient? Why it is electron deficient? Dear students, see the central atom aluminium. Here the aluminium surrounded by 3 bonds, right? 3 bond is equal to how many electron? 6 electron, right? 1, 2, 3, 4, 5, 6. Is it completed their octet? No. It's completed sextet, 6 electron. So they are electron deficient. So nitrogen donated the lone pair and it will give the electrons to aluminium. So it becomes stable. So what is the compound going to form? So aniline, the NH2 group donated the lone pair. So it will get a positive charge. This AlCl3 gain electron. Sorry. AlCl3 gained electron. So it will get a negative charge. So actually aniline should react with the electrophile, the CH3 plus, but instead of that, it's reacting with which one? Anhydrous AlCl3 catalyst. So it's forming a salt. So aniline when react with the, or when it is undergo Friedel-Crafts reaction, it's not giving any product during alkylation and acylation because it's forming or it's making a salt with the catalyst AlCl3. This is the salt NH2 plus and AlCl3 minus. Because of the salt formation, it's not giving the products. Hope you clear? Next question. Diazonium salt of aromatic amine are more stable than those of aliphatic amine. As I told you, when a aliphatic amine, you treated with a nitrous acid. Nitrous acid means HNO2, right? HNO2. When a aliphatic amine you treated with a nitrous acid, it will give you the diazonium salt, and I told you that is unstable. that is unstable, right? When this compound, if it is unstable, immediately it will react with the water and it will give you a alcohol along with the evolution of nitrogen gas and HCl. The same thing we discussed, what happen if a aromatic amine treated. A aromatic amine if you treated, for example, I think better to explain with one of the compound. Aliphatic amine, for example, let me take CH3NH2. When it is treated with HNO2, nitrous acid, NH2 group converted to diazonium salt, CH3N2 plus and Cl minus. I told you this is very unstable. This is the unstable compound and it is immediately react with water and it will give you CH3OH along with the nitrogen gas and acid HCl. Okay. So aliphatic amine, when you treated with a nitrous acid, you can confirm your product is an alcohol. What is the problem with an aromatic amine? If it is an aromatic amine, for example, aniline. For example, aniline, when you treated with a nitrous acid, at 0 to 5 degrees Celsius, NH2 group converted to diazonium. N2 plus Cl minus. You will call benzene diazonium chloride. This is little stable compound. Why stable? I'm just removing this chlorine from the system. So I'm just drawing the structure of the diazonium salt. Okay, benzene. There is 2 nitrogen, right? N2. So nitrogen is connected through a triple bond. The nitrogen contain, this nitrogen having a lone pair because this chlorine is leaving as Cl minus. This nitrogen carry a positive charge. This is the structure of a diazonium salt. Benzene, nitrogen, triple bond nitrogen, the nitrogen with a positive charge, nitrogen with a lone pair. Dear all, when this compound, or how this compound can be stable, it can undergo resonance. How resonance? Nitrogen having a positive charge, so this it's a withdrawing group. So this lone pair, the bond and electron goes here and it will shift it here. We can draw the structure like this. Here nothing happened to these 2 double bond, right? This bond shifted, bonded electron shifted here, so it making a double bond nitrogen. And this triple bond changes to nitrogen, right? A triple bond changes to double bond on nitrogen. Already one lone pair is there. Now one more bond shifted, so it will get one more lone pair, gaining electron, so negative charge. Like that, it will undergo resonance. So while drawing the resonance structure, you can write it. So when this bond electron shifted here, this is the positive charge, right? What is the next resonance structure? In order to cancel this positive, this electron shifted here. So you will get the structure like new pi bonds are here, double bond N, negative charge, positive charge. Now new positive charge here. In order to cancel this positive charge, this pi bonded electron will shift here. So you will get new structure, new positive charge here, double bond, positive. Finally, what happened? It will come back to initial structure. This lone pair coming back and this shifted here. You will get the previous like that. So let me conclude. Normal a aliphatic amine you treated with nitrous acid, it won't become a stable compound because there is no resonance possible. So it will immediately react with water and it will form alcohol with the evolution of nitrogen gas. But aromatic amine, it is unstable compound when it is forming diazonium salt. So it won't undergo hydrolysis faster. So it won't give you the alcohol faster. Okay. Next one, a very important question. Gabriel thalamide synthesis is preferred for the synthesizing primary amines. Yeah, primary amines. The specific question, let me tell you. Gabriel thalamide synthesis is preferred for synthesizing primary aliphatic amine. Primary aliphatic amine. That is the most expecting question for your exam. Why Gabriel thalamide synthesis only used to prepare primary aliphatic amine? Or they will ask you, why Gabriel thalamide synthesis not used to prepare primary aromatic amine? Why we can't prepare primary aromatic amine? See, what is Gabriel thalamide synthesis? Our starting material is thalamide. Thalamide is benzene with CONH, right? N plus NH, sorry, were N minus and H plus. This is called what? Phthalimide. In the first step of the Gabriel phthalimide synthesis, you may treated the compound with which one? Alcoholic KOH, right? KOH. So when you treat it with alcoholic KOH, this OH minus and H plus removed as water, and potassium will come to the place of hydrogen. So you will get benzene, CO, CO. Here we have N, nitrogen with already negative charge. Now the potassium with a positive charge. So initially this is called phthalimide. When you treat it with alcoholic KOH, you will get potassium salt of phthalimide, right? When this potassium salt of phthalimide you are treating with your alkyl halide. So you know alkyl halide bond easy to break. This R plus is there, X minus is there, right? X minus is there. So what happened? This R plus will attack here instead of K plus. This K plus and X minus is removed as KX. KX, you will get the compound benzene. We have CO, CO. You will get N minus and R plus. This is called N-alkyl, nitrogen with an alkyl group, N-alkyl phthalimide. Then you treat it with the NaOH, you will get primary amine. Correct. The question, why we can't prepare a primary aromatic amine? Only why they are preparing primary aliphatic amine? If you are carrying the same reaction with a aromatic amine, let's do. Same thing I'm repeating, phthalimide. Treating with the KOH, you are getting potassium salt of phthalimide. Which step you are getting your alkyl group, your aliphatic group in this step, right? You are adding your alkyl halide. If you want a aryl group, you have to use a aryl halide here. For example, you know, benzene with the chlorine. Here alkyl group, if you want alkyl halide, if you want aryl group, aryl halide, chlorobenzene for example. Here what happening, this alkyl halide bond is breaking and this K and X is removing, R group is substituting. Here such a breaking is possible, dear student. Is this carbon and chlorine bond, can you break it fast? This carbon and chlorine bond in a aryl halide, can you break it fast? We studied in the haloalkane chapter. In haloarene, the carbon halogen bonds are little strong because of the partial double bond character. You know this will undergo resonance. They will create a partial double bond between them. Double bond is a stronger bond. We cannot break it. So aryl halide cannot react with this species because aryl halide having a partial double bond between them. So aromatic amines cannot be prepared through Gabriel phthalimide synthesis because of the stronger bond of aryl halides. Clear? Next one. Arrange the following in the increasing order of their basic strength. We discussed the questions regarding basic strength more. This is a repeated question therefore. Okay. C6H5NH2. What is C6H5NH2? This is the benzene with NH2 aniline. Then a second compound is C6H5 NCH3CH3. Okay. What is the compound? NN dimethyl aniline. Next one is C2H5 twice NH, alright. Then we have CH3NH2. Okay. Dear student, first of all you try to identify which all are aromatic amine and aliphatic or alkyl amines. You know the benzene ring directly connected to nitrogen, therefore it is an aromatic amine. Here also benzene ring directly connected to nitrogen, therefore aromatic amine. These are generally alkyl group, right? So alkyl amines. Which is more stable, dear all? Alkyl amines are more basic in nature here. Here, one amine with the ethyl group, one amine with the methyl group. Which is the best donating group? We know the main reason for the basic character, dear student, electron donating group and electron withdrawing group. Who can increase the basic character? Electron donating group. Okay, electron donating group increase the basic character. Electron withdrawing group decrease the basic character. So ethyl, here we have ethyl group and here we have methyl group. Which is more donating? You know, methyl and ethyl. Ethyl is the more donating group. So he will increase the acidity more, basicity more. So increasing order, right? Increasing order. So let me just number the compound. Number 1, number 2, number 3, number 4. So we can go for the question, dear all. The third one having more basic character. Third one having more basic character because ethyl is the branch. After that, methyl. Fourth one. Okay. Please tell me, in this aromatic amine, which is more basic? Here, nitrogen is there is lone pair. Here also nitrogen lone pair. Why aromatic amines are less basic? We already discussed. The lone pair involved in resonance, not available for donation. Anyway, this nitrogen is connected to two hydrogen atom. This nitrogen connected to two methyl group. You know, methyl groups are donating group. Donating group can increase the basic character. Right. So when you consider 1 and 2, 2 contain electron donating. So 2 is little more basic. So 1. First one least, third one most. Clear? Next. In the increasing order of their basic strength. Another question, dear student, maximum. Okay, this is the maximum. First one is aniline, benzene with NH2. Para-nitroaniline. What is para-nitroaniline? Again, aniline. With the para position, there is a nitro group. Para-toluidine. Dear student, what is para-toluidine? Toluidine means they contain NH2 group and CH3 group. Para-toluidine means para position is the one. Okay, let me just draw the shape of the remaining compound also. C6H5NH2. Again, aniline. Maximum practice this basic character. Okay, most of the cases already discussed. CH3. Then C6H5, CH2, NH2. Okay. Dear all, go to the question. In the first case, all are aromatic amine, right? Because all of them contain the nitrogen directly connected to the benzene ring. Please observe, there is something extra here. You know, nitro group is a very strong withdrawing group. Alkyl groups are electron donating group. Who can increase the basic character? Donating group, right? Let me take this is number 1. Number 2, number 3. So, who having greater basic character, dear all? Who having greater basic character? This is just aniline. This is nitro withdrawing. Withdrawing group, if it is there, it will decrease the basic character. Donating group will increase the basic character. So, third one having greater basic character. After that, let us go to first one, because first one doesn't contain a withdrawing group. Second contain a withdrawing group will decrease the basic character. So second one, 2, 1, 3 is the order. 3 greater, then 1, then 2. What about here? Dear student, these two compounds are aromatic, yes or no? Because the nitrogen directly on benzene ring. But this is not aromatic, this is alkyl one, aliphatic one. Because nitrogen not directly connected to benzene, connected to an alkyl part. So, which is more basic in the sense? There is no doubt. Third one is more basic. Alkyl amine. Among these two, which is more basic, dear all? In this second compound, you can see there is a electron donating group on nitrogen. Electron donating group will increase the basicity. So, second one, then first one. Hope you clear? Okay. Next. In the decreasing order of the basic character, again, dear student, this is ethylamine. You know, it's a primary amine. Again, ethyl group, it's a secondary amine, NH group. This is a ethyl group, again tertiary. This is simply ammonia. We studied that when ethyl group coming as a branch, what is the order? Secondary greater than, tertiary greater than, primary. So, which is more basic, everyone? More basic is secondary one, this one. So, we can say C2H5 twice NH is more basic. After that, tertiary is which one? C2, I think it's a decreasing order, right? They are asking you the decreasing order. So, very careful all of you. Most basic one, let me write first. C2H5 twice NH. This is the secondary. Then tertiary. C2H5 thrice N. Then primary. C2H5NH2, and the least basic is ammonia compared to alkyl amines, right? Decreasing order of basic character. In the increasing order of boiling point, dear all, this is an alcohol, right? It is an alcohol, and this is a secondary amine. This is a primary amine. Let me tell you about amines. What is the basic character? Sorry, the boiling point, right? Okay, boiling point. The boiling point order of amines in the order primary greater than, secondary greater than, tertiary. Dear student, if you consider a primary amine, for example, methyl amine, they're having 2 hydrogen atom. If you consider a secondary amine, it's a secondary amine, NH group, only 1 hydrogen. And what about a tertiary amine? There is no hydrogen or nitrogen. Correct. So primary amines having there are around 3 hydrogen atom on nitrogen. So by using this hydrogen and this hydrogen, the lone pair, it can make a hydrogen bond. So one amine, when you consider, it can make more. If you consider a primary amine, nitrogen contain 2 hydrogen. It's because NH2 group, it can make more hydrogen bonding. So more boiling point. What about secondary? Only 1 hydrogen is there, and tertiary no hydrogen. So the order of boiling point of amines are primary greater than, secondary greater than tertiary because of the availability of nitrogen. Now, but the problem here, there is an alcohol. Alcohol or amine having greater strength of hydrogen bonding. Alcohol. Dear student, alcohol, the element here it is oxygen, amine it is nitrogen. Which is the most electronegative element? Oxygen. So oxygen is the most electronegative element, so it will make the bond very strong with the hydrogen. Okay, so alcohols having greater boiling point, so I can say C2H5OH having greater boiling point. After that, the second compound is a secondary amine and it is a primary amine. Secondary amine and primary amine, when you consider, we know primary amine having greater basic character, therefore C2H5NH2 greater boiling point, then CH3 twice NH is the boiling point. So greater boiling point is for alcohol, then primary amine, then secondary amine. Clear? Then the next one, the last question. In increasing order of solubility in water, which is highly soluble in water. Dear all, the first compound is given as C6H5NH2. This is what aniline. Then C2H5 twice NH. The other one is C2H5NH2. Right, this is the compounds given. Let us identify the compounds. You know, this is a aromatic amine, right? This is a aromatic amine. And these are aliphatic amine, normal alkyl amines. You know, this is a secondary amine and this is a primary amine. Correct. Question, solubility in water. Dear all, when you consider a primary amine and secondary amine, which is highly soluble in water, primary amine, because we said C2H5NH2, right? There are 2 hydrogen on nitrogen atom. It have higher ability to make hydrogen bonding. When you coming to a secondary amine, C2H5 twice NH, only 1 hydrogen. So ability to make hydrogen bonding decreases. Correct or not? Okay. So when you consider primary normal aliphatic amine, primary amines having greater solubility. So we can say it's having greater solubility. Okay. After that. So I can say just in the same order, dear student. Why? This is a primary amine, this is secondary amine. Primary greater solubility because it can make more hydrogen bonding. Aromatic amine solubility we already discussed before. Do you remember? In aromatic amine, it having a phenyl ring. Phenyl ring, you know, it's called hydrophobic part. It's a hydrophobic part. Hydrophobic in the sense not dissolved in water. So generally alkyl amines and aromatic amine, when you consider, alkyl amines are more soluble in nature because they have more hydrogen bonding. Among primary, secondary, tertiary amine, when you consider, primary amine having higher solubility because they have more hydrogen on nitrogen, it can make more hydrogen bonding. So aromatic amines, why less soluble in water means they contain the benzene ring, that is a aromatic. It is just a aromatic hydrophobic part. Clear all of you? So this is the part 1 video for the NCERT solution, the most important and expected type of question for your examination, upcoming term 2 examination. We will meet again with the remaining in the question. That's also very important, especially conversion questions. How will you convert this to other compound? Thank you all. Keep practicing. We have to make a good result for your upcoming term 2 exam. Thank you all of you. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.